Let's throw up any parabola, any quadratic equation. We'll say 3x squared plus 6x. Yeah, I know, I heard it. 6x. No, 5x plus 2. And we'll say less than or equal to 0. Can you grab the door, Caitlin, please? This time I'll trust you guys. Hey, Ryan. So now I can factor this out. Let's see. What times what gives us a 6 that adds to give us a 5? 3 and 2? 3 and 2, 3 and 2. I'll circle my splitter. It's a trinomial difficult, so we factor that out. We get x plus 1 times 3x plus 2. And we'll just say equal to 0. It doesn't matter right now because we're just going to solve for x anyways. So we do that. I get x equals negative 1 and x equals negative 2/3 when I subtract the 2 and divide by 3, right? Okay, so that's the first step, right? Factor and solve for x. What was our next step? Put those numbers where? Hey? Number line, yeah. So let's draw that. Let's plot them. We got negative 1s here and negative 2/3 here. Right? Now what? No, don't draw the arrows yet. We got to find something out first. Check the regions, yeah. So what number do we want to test? 0. Let's plug a 0. 0's over in this region here, right? So 0, 0, 0. Hey, I got a positive. We got positive. And because we know it's a parabola and we've got two x-intercepts, it should be doing the whole concave up thing, so negative and positive like so, right? Because if we were to draw this graph on our number line and superimpose it, whoa, like this, and come up, and oh, look at that pretty parabola that we drew. That's what the parabola looks like. Okay? Well, what am I asking you? Where's the graph what? Less than 0, or where's y, negative. That's kind of what it is, right? Because 0 is in place of y. So where is it less than? Well, yeah, between them. So it's a betweener, right? So now I want to draw my arrows, Caitlin. So I'm going to point where our x values are good. So in there. Is that okay? Okay. So now we got to do our solutions like you were asking, Becca. Okay. So it's a betweener. So I'm going to write it like so. All the x values such that x is where? Well, between the two numbers that we said our solution is. There it is. Right? Because any of these x values in here, right, work. That's grade 9-ish stuff, grade 10-ish stuff. I know because you're supposed to know it. That's it. Open is if it's not equal to, right? So if this was, for instance, less than, if it was just less than, theoretically we would have an open dot, right? And an open dot stating that it's not equal to that. It's equal to, yeah, it's just close. It's around it. That's kind of the idea behind it. Equal to, dead on, yeah. Okay? You don't have to panic too much on that, though, Beck. That's old school. Okay? Should we do a splitter, one of those? Okay. Let's do a splitter one. Everybody's got that? Okay. Alright, so let's do the question, what do we want? Let's do a difference of squares one. X squared minus 9 is greater than what do we want? 16. Let's do that one. It's not really a difference of squares the way it is because I've got it greater than 16. But I can factor it the same way if I bring that 16 over. Or when we've only got the x squared value, I can isolate it and do what with it? Square root it. So either way, I'm going to bring the 16 over though. I'm going to get x squared minus 9, or sorry, minus 9 minus 16. So x squared minus 25. Let's just go with equal to 0 now, because we're just going to start solving and factoring. It doesn't matter if you got greater. Well, difference of squares, what is it? It's minus 5x plus 5. Equal to 0, so x equals 5, and x equals negative 5. Same stuff. Let's plot them on a number line, right? Biggest thing here is getting your numbers in the right spot. That's more of a problem in grade 10. In grade 11, we should know where our negatives go. Test the region. Which number do you want to test? Yeah, so we're going to be checking that middle region, eh? So we plug in as 0. Let's go up to this x squared minus 25 that we had greater than 0. So if I plug this 0 in, I get negative, right? So negative, positive, positive. Because you have to test where it's equal to 0. Okay? If I went up here, no good. You got to come down to this one. Okay? Always remember that. So we're looking for greater than, so like so and like so. Now, it might be, if imagine this one though. Imagine this graph opened down, like this was a negative. If it opened down, this would have to say less than, right? So it depends on this. The sign on these ones doesn't tell if it's a splitter betweener, like in absolute values, you know? This here depends on where your signs are, whether it's a splitter or betweener. It just so happens when the graph opens up like these ones, that's what happens. Okay? So what's our solution for this one? X is less than negative 5. And what else? It's less than negative 5 there, isn't it? Yeah. X is greater than 5, yeah. So there's a solution. There's a splitter.